Welcome back, Focus Learners, to another explainer. Today, we're unpacking something absolutely massive. We're going to trace 70 years of history to fundamentally understand the single most transformative technology powering our modern daily lives, the Internet. From the gripping tension of the Cold War straight through to the bleeding edge of quantum computing, we're going to unpack exactly how we got here, and honestly, more importantly, where we are going next.
Okay, so let's dive right into our roadmap for today. We'll start with the origins of the ARPANET, then move into TCP/IP and the web. After that, we hit the era of connectivity, dive deep into Web 3.0 and decentralization, and finally wrap up with securing our digital future.
All right, Section 1. Origins of the ARPANET, the Cold War Catalyst. We begin our journey back in the 1950s. This was a really tense era defined by the Cold War. A time when profound fears of technological inferiority actually sparked a massive wave of unprecedented world-changing innovation.
Our story really kicks off in 1957. The Soviet launch of the Sputnik satellite completely shocked the United States into creating ARPA, the Advanced Research Projects Agency, specifically to ensure technological superiority. By 1962, a visionary named J.C.R. Licklider was already proposing what he called an intergalactic computer network. He was conceptualizing a world where computers could just seamlessly talk to one another. This wild vision materialized in 1969 when the ARPANET, literally the world's first packet switching network, went live. And get this, just 2 years later, in 1971, Ray Tomlinson sent the very first email, brilliantly utilizing the @ symbol to separate the username from the computer name, a standard that, well, you and I still use every single day. Now take a look at the Defense Advanced Research Projects Agency stamp right there on this declassified 1981 report. So you might be wondering, why was the military so invested in this? Well, the core goal of the ARPANET was to interconnect isolated computers so that totally diverse research centers could share computing resources. See, before this, every single computer center operated completely autonomously. If you wanted to share files or use another facility's software, you faced the extreme, totally prohibitive cost of completely reprogramming the software or reformatting all your data. So ARPANET was basically a practical solution to a massive, expensive logistical nightmare. But what's really fascinating here is the human element of this huge technological leap. Look at that quote, LO. That is the entirety of the very first message ever sent across the ARPANET in 1969 from UCLA all the way to the Stanford Research Institute. The scientists actually intended to type the word login, but the system spectacularly crashed mid-transmission after just 2 letters. No way, right? It's such a humble, kind of funny beginning to a network that now defines all of global communication. Moving right along to Section 2, TCP/IP and the web. Creating a network of networks. As we hit the 1980s and 1990s, this is absolutely the crucial era where those fragmented, clunky academic networks transformed into the foundational infrastructure that you and I rely on right now. Okay, so the absolutely crucial point here is understanding TCP/IP, developed by Vinton Cerf and Robert Kahn. The old protocols simply couldn't handle the growing diversity of connected networks. They were hitting a wall. TCP/IP solved this by dividing data into little packets, routing them all independently, and then seamlessly reassembling them at their destination. On January 1st, 1983, a date officially known as Flag Day, the ARPANET mandated a complete across-the-board transition to this new TCP/IP standard. By standardizing communication, they effectively birthed the modern Internet, transforming it from a single closed network into a sprawling network of networks. This protocol is the exact reason why your Apple smartphone can flawlessly stream a video hosted on an Amazon server today. It's basically the universal translator of the Internet.
But hey, having an internet is one thing, actually navigating it is another entirely. In 1990, British scientist Tim Berners-Lee was working at CERN. He desperately wanted to solve a problem for CERN's 17,000 global scientists. They needed an easy, unified way to share automated information. So he merged the internet with hypertext to invent the World Wide Web. He literally coded the very first web server on his personal NeXT computer. And to keep the world's very first website alive, he had to tape a handwritten note in red ink right to the machine that said, "This machine is a server. Do not power it down."
Once browsers with graphical interfaces, like Mosaic, were introduced in 1993, the web absolutely exploded. It moved from a clunky, text-based tool for physicists into a massive public phenomenon. 1994 was actually dubbed the Year of the Web. To really give you an idea of the massive scale of this growth, by the end of 1994, web traffic had grown so dense it was equivalent to shipping the entire collected works of Shakespeare across the globe every single second. Every second.
And that incredible growth leads us right into Section 3, the era of connectivity, from desktops to our pockets. This is the era where the internet evolved from an interesting little novelty into an absolute commercial and cultural juggernaut.
During the 2000s, the user experience underwent a massive shift from Web 1.0 to Web 2.0. Think about it. Web 1.0 was basically a read-only environment. You sat at your desktop computer and passively consumed static text and images. But Web 2.0, it completely flipped the script. It brought us the dynamic web, enabling interactive platforms, user-generated content, and the massive explosion of social media networks. We went from just reading the web to actively participating in it and, well, creating it ourselves. Following the release of that Mosaic graphical browser in 1993, we see Google arriving on this scene in 1998 to fundamentally organize this expanding universe of information. But the real game changer? For sure, that's 2007. The launch of the iPhone completely untethered the internet from the desktop, putting literally the entirety of human knowledge directly into our pockets. This mobile revolution quickly accelerated into 2015 with the rise of the Internet of Things, or IoT, where everyday physical objects from our cars to our home thermostats became permanently connected to the network.
But of course, the evolution doesn't stop with our smart devices. Let's head into Section 4, Web 3.0 and decentralization, the next digital frontier, to see how all of this builds into our future architecture. So, what exactly is Web 3.0? Well, right now, our internet is largely centralized, right? A few massive tech giants control vast amounts of our personal data. Web 3.0 aims to solve the resulting data privacy concerns and digital monopolies by moving to a decentralized blockchain-enabled network. In this emerging ecosystem, systems are designed to be autonomous, utilizing intelligent contracts and decentralized autonomous organizations to put control and data ownership directly back into the hands of the individual user. It's a huge shift in power. And there are several emerging technologies driving this massive transition. AI and machine learning are going to optimize networks and personalize our experiences. The rollout of 5G and eventually 6G will allow for ultra-high-speed communication with near-zero latency, which enables seamless expansion into the metaverse through VR and AR. But here's the catch. While these emerging drivers will enable incredible intelligent automation and interconnected healthcare and cities, they also bring entirely new cyber vulnerabilities. That is exactly why fields like post-quantum cryptography are racing to secure our data against next-generation computational threats. Which brings us to Section 5, Securing Our Digital Future, Governance and Ethics. As we connect everything from our global financial systems to our personal health records, the stakes for digital governance have literally never been higher. Academic researchers who model the future of the internet basically project two distinct trajectories here. In the optimistic scenario, we achieve a secure, fully decentralized internet. Here, robust and transparent algorithmic governance actively prevents AI bias, it protects user privacy, and it creates a balanced digital ecosystem. Conversely, the pessimistic scenario warns of an environment completely dominated by mass surveillance, escalating cyber warfare, a widening digital divide between socioeconomic classes, and the unchecked spread of AI-generated misinformation. It really highlights that global governments and technology developers absolutely must harmonize innovation with proactive regulations. And that brings us to the end of our journey today. But before you go, I want to leave you, the focused learner, with this lingering, provocative thought. Will our future internet be a secure, open ecosystem for all, or a landscape of surveillance and inequality? The internet is no longer just a cool tool, it is the fundamental fabric of modern society. The choices we make collaboratively today regarding privacy, decentralization, and transparency will safeguard or jeopardize our digital destiny. Thank you so much for joining me for this explainer, and I encourage you to keep questioning the technology you use every single day. Until next time, keep learning.